Hello, everyone. My name is Elijah Love, and today I will be presenting the project that I've been working on for the semester. For this project, I chose to do the IoT environment monitoring system, and it's from sensors to dashboards using an Arduino, Kali Linux, and Grafana. Right, and let's get into it. So for the project overview, the overall goal was to design and implement an IoT system capable of capturing, storing, and even visualizing real-time environmental data. And then some of the core capabilities of this is real-time monitoring, of course, keeping track of temperatures, humidity, light, and sound, data persistence, sharing and storing those historic data in SQL databases, visualization by turning in those raw logs into actionable trends into Grafana that you can visually see. And then pretty much some of the platforms using are a Raspberry Pi acting as the central server for everything. And so you guys have a understanding of how the data flows. This is an overall level view of the data pipeline and its components, comprising of sensors, processes, transmitting the data, parsing the data, and storing and visualizing. So for sense, the sensors capture all of the physical environment data, such as the temperature, humidity, light, sound. Then the Arduino board actually gets all this data, it structures it out into a string format. And then how I'm sending the Arduino data over to my Raspberry Pi is just a USB connection into the Raspberry Pi. And then on that Raspberry Pi, I have Kali Linux running currently, and I have a script that will parse out all the data that's coming from the Arduino and store it into a database. And then we're storing that into sensor database. And then we can use Grafana to pull from this sensor database to then give us the visualization graphs to see all the data and its trends. And this is the hardware pretty much used for the whole setup, the hardware architecture. Main components pretty much being the server, the microcontroller that's on the Arduino, and the sensors that go along with those, which for this part of the project was very fun for me because I have very little experience using hardware and testing out and being able to put together different components. So it was really fun playing around with the Arduino, getting everything hooked up, all the wires connected correctly was a pretty enjoyable process to me, honestly, being a novice. So yeah, like I said, I have a Raspberry Pi 4 that's running Kali Linux that's acting as the server. It hosts the Python script database and even the Grafana server as well. And then on the Arduino sensor kit, obviously is microcontroller and its role as the interface for the actual sensors, bring the bridge of analog and dot and digital signals. And then you can see on the actual Arduino board at the bottom, like A3, A2, A1, A0, there's all these different slots and ports, or I should say pins that components go to make them operate. And so in the case of temperature and humidity, it goes to D3, as you can see on the picture off to the side. And so, yep, that wire that's plugged in to the bottom of the Arduino is the also same wire that's being plugged USB into the Raspberry Pi. So yeah, it's very fun setting all this up, honestly. being able to play with some of the extra components. There was even extra components on the Arduino board that I didn't even get a chance to touch. Alrighty, now to go over the Arduino's actual logic. This is something I didn't really think about when I first thought about the project and going about it. But for the Arduinos, they use a sketch, kind of could be thought of like an image for a computer. So you need to make the sketch for your Arduino depending on what sensors you're going to be using and what you're actually going to be doing with that data. So I had to make my own sketch which included grabbing the data from the sensors for temperature, humidity, light, and sound. This is done using signal processing, and there is a Arduino sensor kit library that I used to be able to not have to reinvent the wheel and make all of these calls myself and functions. So I relied on their library to get the data from the sensors accurately and output put those into a string format, kind of like this with the equal signs, T equals, H equals, L equals, and A equals T being temperature, H being humidity, L being light, and A being audio. Nice. And then you can see me getting those calls for both the temperature and humidity pretty easily, light as well. And for sound, I did an average just to kind of like give it a baseline so it's not too finicky and all over the place and grabbing everything it picks up, which was recommended me doing. So I got an average of the sounds. And then I also have a fail-safe to for me to catch if there is a reading that's giving me not a number or double zeros. So I know that there's something wrong and to kind of give me that insight. Moving along. Sorry. Just some of the sketch continued after getting those in the loop while it's running, and then also printed out all of the outputs for the data, which was cool. Then you can see that data being outputted right here into the terminal, date logged, and then with all the corresponding values that go along with that. And then I also so how the Python and the SQL database integration works. So I have a Python file data logger, and this script opens a serial port on for the device assigned by the Kali Linux to the Arduino, and this is how we begin the actual listening. I also have a parser, or that acts also as the parser, splitting up the data by the equal sign delimiter and then mapping all the keys to the corresponding database. And then, like I said before, I'm storing all of these using SQL insert commands and then also tracking those with the timestamps and storing in their respective columns. All right, and then this is just me setting up the database, my SQL database, setting it up in the beginning, and then I had it describe the table itself. I named it sensor data. So at the bottom, you can see all the different fields, types, and information. Again, this is to store the data that we're getting from the Arduino, piping it to to the yes, the Raspberry Pi, and then parsing this data and storing it into a database, which we will then use to visualize the data. Alrighty, now time for the fun part, the demos. So I'm going to walk through a couple demos for the sensors. First one starting off, we're going to do the temperature and humidity demo. And again, these are connected with the sensor and it measures the temperature and relative humidity. Okay, so let's share the right screen now. Go to the link.
All right, so we're about to demo the temperature and the humidity readings on this sensor. So I'll blow on it real quick to get it hot. All right, and now if we go to the dashboard and refresh our readings, you can see the two spikes for right now for the temperature and the humidity showing that the sensor's got it.
Light intensity. So this demo will demonstrate the sensor being able to pick on very bright and darkness within the room. Let's go.
For the light, I'll just cover one of the sensor for the light to see some of the readings change. Make it dark up in it. All right, so now that the light's blocking, the reading should go down once we refresh. So you can see the light intensity plummet as soon as I covered it up. Uncover it up, let it get some light, refresh again, boom. You can see the light intensity went back up.
Sound levels. So for this, I actually did a loop and I would get the average of the sounds just so the spikes weren't too much because without that, there's no baseline and it'll pick up on every little thing. So this is the best method I've seen to get a good measurement average of the sound in the room. So let's go ahead and continue on now.
Now we're gonna be testing out the light intensity. You can see the light intensity right now is probably around 337. Play some music. If I refresh now, you can see the spikes going up now all the way to 630. Climbing even more, 677. And so yeah, if I quiet down the music now, we should see the data points drop back down to around the normal. And then yeah, we went back all the way 4.6. And now we're completely back around in the 300s again. So yeah.
Yep, that concludes the demos. All right, now time for the data visualization using Grafana. For the data source, I connected my database via the MySQL connector to give the Grafana the ability to see and read from my sensor database. And then for the dashboard configurations, I made four different panels dedicated to each of the graphs for the sensor readings. They're all real time refresh. So if you press refresh, you'll get the newest data from the last couple minutes, and they're automatic. And you can also change the time on the graphs if you want it to be like 15-minute window, or you want to zoom out to see like a 6 hour window if you wanted to. So off to the side, we have the real time sound and light graphs, as you can see. And I have it showing for the 15-minute markers right now. All right, continuing off with Grafana. I just wanted to show the other two dashboards really quick for the humidity and the temperature readings as well. Those there are those right there. Okay. And so if you want to see a bit more of the back end of the actual dashboard and how it's set up, this is kind of how it looks in Grafana. And so I just took a little screenshot. Off to the bottom, you can see data source. I have that set to my SQL at the moment. And then at the bottom, for this one, since it was temperature, it was automatically giving me the temperature readings in Celsius. Since we don't, since we live in the United States, I wanted it to be Fahrenheit. So you can see that I had to do a little math to change it into Celsius. So that is what appears on the graph. And I just changed the y-axis to have that format as well. So yeah, you can like play around with the graphs if you don't want the lines in the graphs, things like that. All the editing and customization of the actual graphs can be done here. Just wanted to give you guys a back end view of that. Okay. So in conclusion, I successfully integrated my Arduino sensor kit with a Linux backend to achieve stable, persistent data logging while also creating a visualization dashboard for the collected data. And I'll be honest, this was probably one of the most fun projects I've done in a while, honestly. The hardware, the software, and all the troubleshooting along with it. I can honestly say I learned and I had fun while doing it. Thank you all for listening to my presentation and watching. I hope you guys enjoyed as much as I did creating the project.